So carbon as an element, it's always, I mean to say, chemistry of carbon. If we take carbon, is it's always tetravalent. It is made up of 4 covalent bonds. To satisfy the tetravalency of carbon, in molecule is satisfied by sharing its valence electrons with the same or different atoms. Example, if it is sharing with same atoms, carbon, if it is sharing with same atoms, carbon valence electrons, if it is sharing with the same atoms of the other carbon atom, then also it is tetravalence is satisfied. But you find that interlinking takes place. That is, some examples I would like to give you. Here if you take carbon and if I take 4 covalent bonds like this, carbon is sharing with different atoms, so the 4 hydrogens are different from 4 carbon, so tetravalence is satisfied for the carbon. Similarly, this is CH4. We go for carbon tetrachloride, CCl4. Carbon is trying to share its 4 valence electrons with the valence electrons of chlorine. This is carbon tetrachloride. Likewise, sometimes it shares with the different elements, like carbon can share its valence electron with hydrogen, it can share its valence electron with chlorine, it can share its valence electron with bromine, and can also share its valence electron with that is fluorine. This is chlorofluorocarbon. This is BrCl of that is fluoro. Bromochlorofluoromethane, and so on. Sometimes the carbon, to satisfy its tetravalency, it forms single bonds or double bonds. Formation of single, double and triple bonds. If you take a single bond, carbon can form single bond between the 2 carbon atoms. Suppose if I take C2H6, it can form single bond between the 2 carbons. Ethane molecule C2H6, it can form single bonds between the 2 carbons. If you take ethylene or ethene C2H4, it forms double bond between the 2 carbons and single bond between the carbon and hydrogen. And it can also form triple bond. As I told you, it can form a triple bond between the other elements, like you can take here, you take HCN. In HCN, between hydrogen and carbon, it can form single bond. Between carbon and nitrogen, it can form a triple bond. Sometimes it can form double bond and single bond parallelly. That is, you can take CH3 CHO, it is called acetaldehyde. So structure, if you take, with hydrogens it forms single bond, and with carbon and oxygen it forms double bond, and again with hydrogen it forms a double bond. Overall triple bond also can be expected between the 2 carbons, that is acetylene C2H2. Also you can expect a triple bond between the 2 carbons, single bond between the 2 hydrogens. All these molecules we are discussing as examples just to prove that the carbon is tetravalent in nature. What is interesting is, in every structure of the molecule, whatever you are trying to see here, for example, if you take methane, carbon is tetravalent, you are finding that the carbon is having 4 bonds, 1 2 3 4. You come here, that is carbon tetrachloride. Again here you are finding that the carbon is having 4 covalent bonds, so therefore it is tetravalent in nature. You take any damn structure of the carbon compound, you have 4 bonds surrounding the carbon, proving that the carbon is always tetravalent. You take ethane, if you take individual carbon, 1 2 3 4 bonds. Again the next carbon, if you take 1 2 3 4 bonds. You take ethylene or ethene, again each carbon 1 2 3 4. Again take the adjacent carbon 1 2 3 4, tetravalent. You take any structure, you take the carbon in hydrogen cyanide, again the carbon is having 3 bonds on the right side and 1 single bond on the left side, carbon is tetravalent. You take acetaldehyde, in carbon between 3 hydrogens, tetravalent, carbon and oxygen double bond, carbon and hydrogen single bond.